When moving on to the last part of the chapter now, which is modelling questions, which tend to be quite challenging. Make sure you've had a go at that starter there. So the starter touches on a point that we talked about last time, which is when we're dealing with something like sine, we know that it has a range between 1 and -1. So if you have 11.5 minus half of a sine graph, you know that this will be between 0.5 and -0.5. In other words, you know the pressure in this question will always be between the numbers of 12, minus 0.5 will give you 12, and minus 0.5 will give you 11. Okay, the values for this will always be between 10 and 11. And that's sort of what these questions here touch on. Okay, so we're going to do that, but with slightly more difficult questions. So the first part of the question looks very, very similar. So express this in this form. We've dealt with that earlier in the chapter. What is r in exact value? So that will be 9 squared 81. So this will be root 85, for example. Okay. The value of alpha, that's when we write it out and we match the pieces and we can find out what alpha is. State the maximum value. Again, we kind of talked about that before, and the value at which this occurs. We talked about this before as well. So I'm just going to reveal the first part just so I can talk through it a little bit more. So you end up with root 85, and here's your translation. So all of that part there can be written as root 85 cos of theta plus 0.2187. It's said 4 decimal places. So what's the maximum value? Well, there's a cos graph. And this cos graph goes between 1 and -1 normally, but it's been stretched by root 85. So root 85 and minus root 85. It's a number that's a little bit more than 9. So what's the maximum value? The maximum value is root 85, isn't it? That's it. That's going to be the maximum value. When does it occur? Well, minus 0.2187, that means that the graph has been moved towards the left. So this is not accurate, okay? But the graph looks something like this. So it used to occur at 1, but it doesn't necessarily, sorry, it used to occur at 0, but it doesn't necessarily occur there anymore. It might occur over here. So one way that you can solve this is by doing an equation. So you can say root 85, that is the maximum height, is equal to, what have we got here? Root 85. So what I'm saying here is the maximum value. When is the graph equal to the maximum value? Well, you can solve this one here. Okay, just make sure that the value is between 0 and 2 pi. So what they say here is the value, well, what they're talking about here, they're talking about using symmetries. Okay, they're talking about using symmetries here. So the value you'll get is 6.06. So if you solve this one, you can just do this with a calculator and so on. You'll get 6.06. That's when it's root 85. So the first part of the modeling then is really quite similar to what we've done so far. I want to focus on the other part then. Okay, so root 85. I'm just going to write down root 85 cos theta plus 0. I think it was 2187, but we're not really that fussed about this number right now. So I want to talk about part C and part D. So Ruth models the height above the ground of a passenger on a Ferris wheel using this equation here. Now this is part C, so there must be some link to part A and B, where height is measured in meters and t is the time in minutes. Underline that might be important. Calculate the maximum value of h predicted by the model and when this first happens. So what we need to do first of all is we need to try and spot the links in the question. So this has got sort of something to do with this part here, hasn't it? Notice there's sort of like a negative, the signs are the wrong way around, but it looks like theta has been replaced with pi t over 5. That's the first thing we need to notice. And then how to rewrite this? Well, h equals the 10. The 10 is like a plus 10 or something. That's sort of separate. 10. And now the signs are all the wrong way around here, aren't they? 9, minus 2, 2. So what about if I did something like that? What if I factorized the negative out? Well, is that the same if I put the 9 there and the minus 2? Yeah, that would work, wouldn't it? So I'm going to replace this part here with what I found out in A and B, which is all of this. So root 85 cos theta plus 0.2187. That's another way of me sort of writing that equation there. So we've replaced that cos sine part with what we did earlier in A and B. And you might sort of think, well, that doesn't look very nice, but actually it's much better because before it was about cos and sine, and now it's just about cos. So you can do something with this, okay? Now, what's the new maximum? So we're doing 10 minus this sort of like this root 85, Well, again, it's the cos graph, and it's been stretched. So its new range is between root 85 and and negative root 85. So when do you get the greatest value? Well, you get the greatest value when you have a double negative. So this will be your new maximum, okay? 10 plus root 10 plus root 85 is the maximum value that this expression can take, okay? Don't need to do any differentiation for that at all. Now, when does it first happen? Okay, well, you probably just want to solve at this point. So you're saying that the height equals 10 plus root 85. So that's the value. And we're saying it needs to be equal to the expression, which is 10 minus root 85 cos of theta plus 0.2187. So in other words, you need to solve this one here. Okay, you might notice some similarities with the previous question, but I think when it's getting a little bit more complex, I think I would probably just solve this one here. Okay, so if you just work forward with this question, you can solve your value there. Okay, if you do spot a link between B part 2 and C, fantastic, but I think that's the way I would think of it to start with. Okay. Part D, I'm not going to discuss part D in this question because that's really going to make the video quite complex. Okay, but you feel free to have to have a go to use this hint here on your own and to check with your teacher. Okay, so I mean that's it really. You have to be very confident in some of these earlier skills that we talked about. So make sure that you can express things in a given form like this, that you can find the maximum, and then, when the maximum occurs, you get a lot of marks for doing those first few things. And then the questions here at the end of the chapter, they talk about a modeling situation. So, it's not 3 cos theta, it's 3 cos 15t plus 4 sine theta plus 4 15t. So you need to take your result from earlier, sort of substitute that in, and then do some reasoning with this part here. You can use the hints there. Pause the video to have a go, and I'll reveal those. Okay, the working out, so the solutions might differ quite a lot from what you've done, and you have the same answer. That's fine. There's sort of like different ways that you can write the working out, especially for C and D. Okay, and there's another question there. for you to have a go at if you pause the video and slowly work through the steps. And remember, a question like this should take you a bit of time. Okay. And again, you've got some answers here. Watch out for part D here. It talks about the nearest minute. It's sort of the thing that might catch you out there. Okay, and that takes you to the end of the chapter. So it's quite a challenging chapter, but that's because this is really exploring trigonometry as far as it goes in the course. So definitely make sure that you're able to at least do parts A and B. C and D are certainly more challenging, but if you're going for top grades, these are the questions that you want to answer. And in fact, they are fairly predictable after you practice quite a few of these.